Welcome to today's episode on switchgear innovation. We're exploring how ODS is transforming energy storage motor control. Our expert joins us to discuss why moving from discrete relays to parameterized control is critical for modern high-voltage systems. Let's start with the limitations of traditional setups. What makes them so challenging to maintain?
Traditional energy storage circuits use a patchwork of timers, contactors, and thermal relays. They work, but create three major problems. First, logic is locked in wiring, so any change requires rewiring like rebuilding a house. Second, protection is limited to basic overloads, missing stall or excessive cycling. And third, configuration exists only in drawings.
So the PSME309 was designed to address these issues through integration. What makes its architecture fundamentally different?
It replaces scattered components with a single controller containing all logic, protection, and configuration. Instead of jumpers and relays, we use parameterized settings, start time, current limits, 24-hour operation counts, adjustable via front panel menus. This transforms handcrafted wiring into data-driven control that can be modified without rewiring.
Protection visibility has been a major gap. How does the PSME309 provide comprehensive monitoring?
We've built in multi-dimensional protection, overcurrent detection for stalls and overloads, 24-hour operation counting to prevent excessive cycling, and overtemperature monitoring. These work together to catch both immediate electrical faults and cumulative mechanical wear, something discrete thermal relays can never do. The front panel displays these alarms clearly, so operators see exactly what's happening at the cabinet.
Let's discuss the parameterization advantage. How does this simplify setup and adjustments?
Parameters turn experience into repeatable engineering. For example, a 15-second start timeout or 10-amp current limit becomes a configurable value instead of a hidden relay setting. Engineers set these via the ODES keypad and confirm values on the LED display. During commissioning, you're not rewiring, just entering numbers that match the motor's torque and inertia characteristics.
What engineering details make this practical for real-world installations?
The PSME309 is built for field use. Compact 104.7 x 95 x 45 mm housing fits easily in existing cabinets. Simple button interface works with gloves, and it accepts wide voltage inputs from 110 to 250 volts AC/DC. We focused on visibility parameters, display as start time 15s instead of codes, and reliability, with 2 kV isolation and EMC immunity for substation environments.
How does this transform troubleshooting and maintenance?
Before, finding a stall issue meant tracing wires and checking multiple relays. Now operators see overcurrent alarm on the panel, review the 1OA setting, and adjust if needed, all without SCADA or laptops. In one wind farm application, this reduced diagnostic time from 2 hours to 15 minutes during a critical maintenance window.
What quantifiable value does this deliver to utilities and EPCs?
4 key benefits: 40% less wiring through integrated I/O, predictable protection that reduces unplanned downtime, standardized parameters that simplify cross-project engineering, and local control that empowers field teams. It turns "it runs" into "it runs right" across all installations.
So this isn't just a component upgrade, it's a control philosophy shift.
Precisely. The PSME309 moves energy storage control from hardware-dependent to software-defined, where logic lives in parameters instead of wires. This is how modern switchgear should operate.
For listeners struggling with relay-based systems, what's your call to action?
Request our energy storage control kit for parameter templates. Consult ODS engineers on setting optimal thresholds, and transform your control circuits from maintenance headaches into engineering assets.
Thank you for explaining how the PSME309 is redefining energy storage control. Learn more at www.ods-electric.com.